All right, here's part 2 of our midterm review. So we've seen a lot of material so far. Now we're on the kind of the home stretch. So we're looking at number 59 now, in a new section, 3.4. And if you remember, back in section 3.4, we were just kind of talking about rates, like your rate of speed or the rate at which something is changing with respect to time and things like that. So section, we won't be doing a lot of graphing lines and things like that. It's just really finding rates in real life situations. So here, let's look at number 59. So it says at 4 p.m., Jesse's Honda Civic was at mile marker 17 of the Interstate 290 in Chicago. At 4:45, okay, I think what really matters there is that how much time has passed. 45 minutes, right? It started at 4 p.m., 4:45, that's 45 minutes later. Jesse was at marker 23, okay. And then part A asks us to find his driving rate, his or her, I guess Jesse could be a girl or a boy, huh? Driving rate in number of miles per minute. So I've got time already, minutes. How about miles, though? So how are we going to find out how many miles they drove, this person? Well, they started at mile marker number 17, and then they hit mile marker number 23. How many miles is that? You take 23 and subtract 17, that's 6 miles. Yeah, because if they went from mile 17 to mile 23, that's 6 miles in between. All right, I think we got it. So part A, they want us to find the driving rate in number of miles per minute. So remember, in this section, we said you want to set up a fraction where the numerator has the first unit that they mentioned, miles, and the denominator has the second unit they mentioned, minutes. So I wrote over here that there were 6 miles, and then there were 45 minutes. So we got 6 over 45. That doesn't come down to a nice number, but at least it reduces a little bit. I know 3 goes into both of those. 3 goes into 6 twice, and 3 goes into 45 15 times. And now you don't have to keep the units there. The units I just kind of wrote to remind myself where each number is going, to remind myself it's not 45 over 6, it's 6 over 45. But now I can write miles per minute in words. And notice in part A it says, leave your answer as a reduced fraction. So we're good to leave it like this. That's what they want. But you could write it in a complete sentence, though. That might be nice. Jesse drove 2/15 miles per minute. All right, how about part B? They want to still find Jesse's driving rate, but this time in number of minutes per mile. So now our fraction will have minutes on the top, because that's now the first unit they mention. So you got miles on the top minutes on the top per mile. That's going to be the second unit they mention. Miles, okay. So minutes is pretty much the same fraction, but upside down, right? 45 on top, 6 on the bottom. This time it says they want it as a decimal number. So I'm going to divide 6 into 45. Let's see. You could reduce that fraction first and then divide, and you'd get the same answer either way. Let's see, 6 times 7 is 42. If I put a decimal and then a 0, bring down the 0. There we go, 7.5, okay. 7.5, and then since they said minutes per mile. There we go. Okay. I think that was pretty good, right? It seems easy now. I think that it's been so long since we saw that material. I guess we've seen more difficult stuff since then, probably. That's why. Okay. So this next example, we have a graph here. It shows kind of how a washing machine's value has changed over time. So it looks like the horizontal axis, this is how much time has been, I guess that's how much time has passed. So 0 must be when they first bought the washing machine. 1 is in 1 year later, 2 years later, on and on and on until 5 years later. And then the vertical axis is how much it was worth. How much is this value, how much is the value of this machine after that many years? So what does it want us to do? At what rate is the washing machine's value changing? In dollars per year. Okay. Well, one way to go about this is, so we need to figure out, like in number 59, we figured out kind of what change happened, you know, how much time passed and then how many miles had passed when this person was driving. So now we need to figure out how much money the value of this washing machine has increased or decreased, and then how many years have passed. And that'll be the rate. So it says, at what rate is the washing machine's value changing? Dollars per year. So you need dollars on the top and then years on the bottom. But this time, I guess not like in number 59, they just told us these are specific things at 4 o'clock and then at 4:45. This is what's happening, you know. But here we have a lot of different points to choose from. So actually you can kind of narrow in on any 2 points on this entire line and figure out the change from there. So it really doesn't matter. I'll just pick maybe this top left corner here, 0, 500. And then maybe, doesn't matter, maybe this guy right here. So any 2 points you can think of. Let's see, what point is that? It's above, it's kind of above 1.5, huh? Which isn't very nice. So maybe I'll make sure to choose a point that's at a nice value. Maybe the one that's above 1. Excuse me, like, right here. I'm going to zoom in on this guy. What point would that be? Well, it's above 1 on the x-axis, which represents the number of years. And then it's to the right of 400 on the kind of y-axis, which represents value. So we'll have to figure out what kind of change in value has it had and how many years have passed from one point to the other. So change in value is basically how far did it go from here to here. Well, the top point, its value was 500, and this bottom point, the value is 400. So it was a net change of $100. And then the horizontal change from here to here is how many years have passed. So where this point was, notice it's above 0. So that must be right when they bought the washing machine. The second point we chose was above 1. Only 1 year passed between the two. But if you had chosen a different point, say the one above 3, way down here, you're actually going to get the same rate as us. Your numbers may look different, but once you reduce your fraction, it'll be the same fraction as us. So the washing machine's value is changing at $100 in 1 year, but I should say that it's negative because notice the value is decreasing. It goes from $500 to $400. It's going down until here it's actually worth $0 5 years later. So make sure it's negative if the amount is decreasing. And in our case, the amount is money decreasing. So we need a negative. Yeah, it's not like in the previous example, this person was driving, so his speed was increasing, or, yeah, that kind of thing. Or no, sorry, not his speed. The number of miles he was going is increasing. That's why it was positive. This time, the number of dollars that this thing is worth is decreasing. So it's $100 in 1 year, but we can just reduce that. 100 over 1, that's 100. And then say it in words, dollars per year. So if I want to sum this up in words, I would say the washing machine's value changed at a rate of negative $100 per year. Yeah, just if someone sees the negative, they'll know that means the rate was decreasing, or the number of dollars was decreasing. It's not like it was worth $100 more every year. It was worth $100 less every year. So that's really the only thing to be careful of, is you might see rates. If it's increasing, you're positive. If it's decreasing, you're negative. So these problems in the next section, they're actually kind of similar. We're given a line. For example, if I focus on number 61, we're given a line and have to kind of figure out what the slope is. So remember, slope is rise over run. We saw that in this section. Rise over run. So what I do is focus on 2 points and figure out how far did you rise from one point to the other, and then how far did you run. And keeping in mind that up and right, those are the positive directions. Because up on the y-axis is positive, and right on the x-axis is positive. But if you were to go down or to the left, those are the negative directions. So if you go from one point to another and you're going up or to the right, you're going to keep it a positive number. But if you were to go from one point to the other and you were going down or to the left, you have to put a negative on that number because you're going in the negative direction. So let me focus on 2 points. It doesn't really matter. Just try to make them, like, for example, this guy, it's right on it's right above a whole number 3, and it's directly to the right of a whole number 4. Try not to pick a number like if I pick this point right here, that's not a nice point because I don't really know where it lands here. I can estimate, I don't really know where it lands here. So you kind of want to pick one that's on the corner of the grid, like we did for this one, 3 and 4. Ah, shoot. Sorry. 3, 4. So that's what this, that'd be this point here, 3, 4. And you can choose any other point. Just try to make it so it's on a corner of the grid, like maybe this guy right here, for example. That's a point 1, 0. Alright, so the slope will be, when I go from one point to the other, how far did I rise? So I would go up 4 units to get from the first point to the second point, and then I would run 2 units from here to here. And notice that both of those were in the positive direction. I went up, which is the positive direction, and then to the right, which is also positive. So both numbers get to be positive. 4 over 2 would be your slope. And then that reduces to just 2. So it must be that our slope is 2. Or you could write 2 over 1 if you wanted to. But I think if you just write 2, it's a lot simpler. So yeah, that's really it for these problems. Try to grab 2 points. Try to make it so that they land on the corners of the grid. Like in this next problem, here's a point that kind of looks like it's on the corner of a grid. It's above 4. It's to the right of 1. And the other point look like it's in the corner of the grid. Not a lot of them. Maybe this guy on the y-axis. It looks like it's right at 4, huh? Alright, and then it doesn't really matter which point you start at, too. You could start at this one, and then rise and run from there, or you can start at this one and rise. You're going to get the same slope either way, don't worry. No matter which point you start at. And no matter which of the points you choose, as long as you choose points that are on the corners of the grids. Alright, so from one point to another, I guess I'll start at this lower point here. How do I get to the next point? How far would I rise? From here to here, I'm going up 1, 2, 3. 3 units. And that's upward, so I'm keeping that number positive. When I run, I'm going to the left. 1, 2, 3, 4 units. But remember, the left is the negative direction. So this would be a -4 run and +3 rise. So slope should be 3 over -4, but as you know, you probably see the negative off to the side of the fraction. They'll probably throw it off to the side. Alright, last one. I think we're getting the hang of this now, if we weren't before. We got a nice line. Let me see. I'm going to try to find... For sure, this looks like the same point as the last one, huh? Hits right at 4 on the y-axis. And actually, this point on the x-axis is pretty nice, -3. So those look pretty good. If you see another one that looks like it lands on a corner, then that's probably the best one to choose. Those are the only ones I'm seeing. So the slope should be rise over run. Doesn't matter which point you start with. I always seem to start with the point that's lower than the other. I don't know why. I'm going to rise, go up to get to the next point. That would move me up 4 units. And it's +4 because I'm going upward. And I would move 3 units to the right. And that's also positive because I'm going to the right, because that's the positive direction. So our slope this time is 4/3. A whole number, or not a whole number, sorry, a positive number. Alright, I think we got it. So now, number 65, we're going to do kind of like we did in the previous problem. Just, we're not going to have a nice graph to count how far do we go up, how far do we go down. This time we're given 2 points on a line, and we just have to use our slope formula. If you remember, slope is y2 minus y1 over x2 minus x1. So as long as you label them correctly, I'm going to label this guy x1, y1, because that's the x value and the y value of the first point, and then x2, y2, since that's the x value and the y value of the second point. And then just replace them. So y2, that's -1. And I'm subtracting y1, which is here, 9. Okay. That's over x2, which I labeled here as 4. subtract x1, which is -1. So be a little careful because I have a negative there, and it's easy to miss one of those. The green one's from the formula itself, from the slope formula. The red one's from the fact that x1 was a negative number. Now all I have to do is simplify that. So I have -1 minus 9, that's -10, over 4 minus -1 is +5. And that happens to reduce to a nice whole number. Even though it's negative, it's nice. Slope is -2. Beautiful. All right. Oop, I think I missed one, huh? Hello. I skipped number 64. Oh well, it's the same kind of thing, so let's try this one now. I'm going to use the same formula. y2 minus y1 over x2 minus x1. So this is x1, y1, this is x2, y2. Alright, and if I replace all those values in the formula, y2 goes for -3, y1 is -1, and the denominator x2 is +2, minus x1 is -5. There we go. A lot of negatives in this one. This one's actually trickier. So in the numerator, the negative becomes a positive, so it's really -3 plus 1, which is -2, over 2 minus -5, that's 2 plus 5, or 7. And that doesn't reduce, but you can make the fraction look a little nicer by putting the negative off to the side. There we go. So -2/7 would be the slope on that one. Now number 66, this one is probably, if you want to memorize it, that this type of problem has a slope of bleh, that's good. But for me, I'm like, you know what, a couple problems back we had to graph this guy, or something similar to it. Remember, when you have x equals a number, the line, that means it's a vertical line through that number, 1, 2, 3, 4. So for me, I always just graph it kind of quickly in my head and then think, what kind of slope would that have? I know these guys, the ones that are just x equals something or y equals something, their slopes are either 0 or undefined. When I see this line, the one I just drew, I don't think that looks like it has a slope of 0. Because a slope of 0 would imply it has no slope at all. It's just like a flat horizontal line. This looks like, this line is so steep, its slope is actually undefined. It's so dang steep. So I don't really memorize it. You can memorize it that anything of the form x equals bleh has slope undefined. And then anything of the form y equals bleh has slope 0. But for me, I already have so much to memorize for these problems anyway. I usually just draw them over again and then kind of figure out what their slopes are by looking. So yeah, for example, y equals -1. This guy in number 67. If you were to graph that line, like we saw before, y equals -1, that's a horizontal line through -1 on the y-axis. And a horizontal line, of course, if you think, how steep is that line? Well, if you're walking across that line, there's no slope at all, right? So the slope would be 0. So it's up to you if you want to memorize that. Lines that look like x equals something have undefined slope. Lines that look like y equals something have 0 slope. Or if you get them mixed up, all you have to do is kind of draw their graph and say, which one of these guys would look like it should have 0 slope and which one looks like it should have undefined slope. So yeah, not too big a deal, but still. Okay, next section. Now we're graphing a line. This is usually everybody's favorite method on graphing a line, using the slope and y-intercept. So remember, this is supposed to be of the form, oops, sorry. It's supposed to be of the form y equals mx plus b. So remember, the slope is sitting right in front of x, coefficient of x, and then this y-intercept, well, at least the y value of the y-intercept, it's 0 comma, whatever the number adding or subtracting at the end is. So that means here our y-intercept is 0 comma 2, and our slope must be the coefficient of x, which is 3/4. But remember, you want to start with the y-intercept, so I'm going to plot that point first. 0 comma 2, that's right here. And then from there, I only need one other point. I'm going to rise and run with the slope tells me to rise and run. So the numerator of the slope is 3. That means I'm going to rise 3 from the point I just drew. 1, 2, 3. If I go up 3, I'm landing right here. But don't make a point yet. I'm going to erase that. You still have to run 4. So from there, I'm going to run. +4 is to the right. 1, 2, 3, 4. I'd go to the left if it were negative 4. So there's my second point. I'm gonna erase that other point. And now just connect those points. Whee! All right, that's good. And remember, a quick little check is that if your line goes up from left to right like this, if you look at it from the left side to the right side, it's going upward. That should have a positive slope. Which we do have a positive slope. 3/4 is positive. If we were going the other way like this, that would be a negative slope. So that's a good check. Just kind of remembering which one of those should have a positive or negative slope. That might keep you from making a mistake, or if you graph it wrong with the wrong slope, you might catch yourself. Let's try this next one. Same directions and everything, just kind of a weird looking equation now. So the y-intercept, it's always going to be 0, comma, whatever the number adding or subtracting at the end is. And make sure to keep the sign. Don't just put 3. It has to be negative 3 there. And the slope is negative 1/5, right? And notice the negative's off to the side, but this is where you have to assign the negative to either be on the top or the bottom. I think I told you guys in the lecture video, I always just put it in the top so I don't confuse myself. I just always put it on top. Alright, so I'm going to start with the y-intercept. 0, comma, negative 3 is down here. Then I'm going to rise the numerator, negative 1, which means I'm going down, because that's the negative direction on the vertical axis. And then I'm going to run 5, which is positive, which means I'm going to the right, because that's the positive direction. Alright, so from the point I just drew, I'm going to go down 1, because I'm rising negative 1, and from there I'm going to run 5. 1, 2, 3, 4, 5, and land right here. There we go, and try to connect those dots, make a nice little line. And notice the slope is negative, so I should be seeing a line that looks like, how do we draw it over here? That's true, it is sloping kind of downward from, if you look at this line from left to right, it is sloping downward. Which is a good sign. If I saw it sloping the opposite way, I'd say, uh-oh. That's only if the slope was positive, but I have a negative slope, obviously, here. But I think we're doing good. So let's try this guy. Graph the line by using the slope and y-intercept. Same directions, just a lot more practice. So what's the y-intercept we got? 0, comma, negative 1. And the slope is the coefficient of x, which is 4, but we better make it into a fraction so we can think of it as rise over run. So keep that in mind, yeah, whenever your slope is a whole number, make it a fraction by putting it over 1. So I'll start at the y-intercept. Where's that guy? 0, negative 1 is right here. And from there I'm going to rise 4. Since that's a positive number, I'm going up 4. Then I'm going to run positive 1, that's to the right. Now, so from the point I've already plotted, up 4 is 1, 2, 3, 4 right here. And then I'm going to run 1 to the right. Here he is. Perfect. Okay, and does that look like the type of line that should have a positive slope? Yeah. It's going upward from left to right, which means it should have a positive slope, and that's what I have. Good stuff. Okay, let's try this next guy. Graph the line by using the slope and y-intercept. Okay. So notice this one, it doesn't have y isolated, so this is the first one that's not of the right form. It's supposed to look like y equals mx plus b. We can't tell what the slope and y-intercept are until y is isolated. So they're trying to trick us here. They're trying to make us think that we can figure out the slope just by looking at it right now, but we can't. We first have to isolate y, and then we'll be able to graph it by, figuring out the y-intercept and slope. So to isolate y, I'd probably move the 2x over first. Then negative 5y by itself. And I could put 15 minus 2x, but I'm going to write negative 2x plus 15, because I want the right side to look more like this guy. The x term first and then the constant term. And the last step to get y by itself would be divide by negative 5. And instead of dividing both sides by negative 5, like the entire right side, I'm going to divide individual terms because it'll be easier to simplify that way. The left side will just become y. The right side you have negative 2 over negative 5, that's positive 2 over 5x. And then positive 15 over negative 5 becomes negative 3. There we are. Now it's finally in that form, y equals mx plus b. The y-intercept must be 0, comma, negative 3. And the slope must be the coefficient of x, so 2/5. That's the rise and the run. There we go. So let me start with the y-intercept. 0, -3, that's down here. Then from there I'm going to rise 2, that's up because it's positive. And then run 5, that's to the right because that's also positive. So from there up 2, 1, 2, to the right 5. 1, 2, 3, 4, 5. Here we go. Landing right there. Up 2, right 5. Oop, I missed it. Ah, well, whatever. Alright, so after all that practice, you probably have a good, good review of all that stuff, and you probably remember it pretty well. Alright, this is where we got to go back and remember what it meant for two lines to be parallel. I mean, I think we can visualize parallel. Remember that means they don't intersect, so they're like this. Perpendicular means the two lines intersect at a right angle, like a nice 90-degree angle. But how are we going to tell? Do we have to graph these guys or what? But graphing them would actually be too time-consuming. There's a better way to do it. Parallel, remember, two parallel lines have the same slope. So if you see two lines and you say, oh, their slopes are the same, that means they're going to be parallel. And they're perpendicular when, let's see, how do you say it? It's their slopes are reciprocals with opposite signs. So yeah, remember that two lines are perpendicular. If you look at their slopes and their reciprocals, for example, if you saw 2/3, and what's the reciprocal of that? 3/2, except they have to have opposite signs. So one of those better be negative and one better be positive. So let's say one of them is -3/2, one's positive 2/3. Those would be an example of two perpendicular lines, if those were their slopes. Alright, now that we know what to look for, I think we can kind of start thinking about these examples here. So number 72, you got two lines, or two equations of lines, and they want to know if they're parallel, perpendicular, or neither. What we're going to have to do is try to take each of them one by one and try to solve for y to tell what the slope is. And then we can compare their slopes and say, are they the same? Well, then they're parallel. If are they opposite signs and reciprocals? Well, then they're perpendicular. But if neither of those is happening, then it must be neither. Alright, let's take the first one here. We got y plus 9 is 3x. Alright, if I want to isolate y, because that's how you have to get it. You can't identify the slope until it's in that form, y equals mx plus b. And then we'll know what the slope is. But if I want to isolate y, I'd better move the 9 over. So then y would be 3x minus 9. Alright, now that it's in that form, I could identify the y-intercept if I wanted to, but really what matters here is the slope. Because I just need to compare slopes to tell if two lines are perpendicular or parallel or neither. So there's the first guy. What about the second guy? I want to see what his slope is. That's 3x minus y equals -2. Alright, if I try to isolate y, I probably move the 3x over first. And then negative y is by itself. And I'm going to write it as -3x minus 2 instead of -2 minus 3x, because that way it looks more like mx plus b. But now I need to get rid of that negative, so I'm going to multiply both sides by -1. Kind of distribute it onto the right side. The left side, it would just change the sign to a positive y. -1 times -3x would be positive 3x. -1 times -2 would be positive 2. But all that really matters there is the slope, and the slope is the coefficient of x, which is 3. Now I can compare. Notice that these have the same slope, which means that the lines are parallel. So if you were to graph those two lines, which I don't know why you would, this is a lot easier, I think, they would be parallel lines. Alright, that's pretty much how B and C are going to go. You're just finding their slopes by isolating y, and then comparing them. Are they the same? Are they opposite reciprocals? Blah, 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 blah. The top one, notice that's already in the right form. Y equals 4x plus 1, because it already has y by itself. I can go ahead right away and say slope is 4. So now all I have to do is take the other line, the other equation of the line, 8x plus 2y is 5. Isolate y there, and then see what the slope is and compare them. But to isolate this y, I need to move the 8x over first. minus 8x. So 2y equals negative 8x plus 5. Then I'll divide both sides by 2. Every single term gets divided by 2. And that should let me know what the slope of this line is. Negative 4x plus 5 over 2. The coefficient of x is the slope, that's negative 4. Alright, so comparing these slopes, notice they're not the same, because one's negative and one's positive. But they're also not reciprocals. So since they're not the same, that means they're not parallel. They're not reciprocals, that means they're not perpendicular. Because if they were perpendicular, then, like if this guy's slope was 4, the other guy's would be 1 over 4, negative 1 over 4. These aren't reciprocals though, 4 and negative 4. They're opposite signs, yeah, but perpendicular not only requires opposite signs, it also requires one to be regular, or some kind of fraction or whole number, the other one to be the reciprocal. So this would be neither. Okay, last one of this type. So I need to do the same thing. Unfortunately, this one has, both of these don't have y by themselves, so I'm going to have to work a little bit on both of these. X minus 2y equals 3. If I want to isolate y, I'd better move the x over. Then I'll have negative 2y equals negative x plus 3. And then lastly, to get rid of that negative 2, I'll divide both sides by negative 2, every single term. Oops, sorry. That'll leave me with y equals, it's a negative over a negative, so it's a positive. You could write x over 2, and then a positive over a negative is a negative, 3 halves. But you know what I want to do is extract the slope. So I think x times what would be x over 2. So what could you multiply by x to make it x over 2? That would be a 1/2. 1/2 of x is x over 2. So you kind of have to do that, kind of extract whatever the coefficient is so it can be just something times x. Otherwise it would have been hard. How would I figure out the slope looking at this guy, you know? X over 2. But the slope of this first, or the top line, or the equation of the top line is 1/2. Now let's try the second one. Second one's 4x plus 2y is 0. If I want to solve this for y, I'd better move the 4x over. I'll subtract it. Then I'll have what? 2y by itself. 0 minus 4x, you could just write negative 4x. And the last thing is I'll divide by 2. So y must be equal to negative 2x. Alright, so the coefficient of y is negative 2. That must be the slope. But notice these guys, they have opposite signs. Opposite. Because the first one was positive, this second one's negative. And they're reciprocals. 1/2's reciprocal is 2 over 1, but that's the same as 2. That means they're perpendicular. Good, alright. So we kind of had a taste of one of each. Parallel, perpendicular, neither. Alright, this is probably the toughest section, I think, in this chapter. Yeah, definitely, where you're, usually they give you the equation, and you have to do things like graph it or figure out the slope. That's actually a little easier. When they give you the, I guess, knowledge about the graph or the slope or things like that, and they tell you to go find the equation, that's actually pretty tough. So usually what we do is we'll use the formula they've already been used to, y equals mx plus b. And somehow we'll have to figure out what's m and what's b. If we have those, we'll just go ahead and replace them. Put the slope there, put the y-intercept there, and then we'll be done. So we need to see if we can get clues from what they tell us in order to fill in slope and y-intercept. Well, first, notice they just give us the y-intercept. 0, 1/2. So that means b is 1/2. Because remember, up here, whatever the number was, where is it? Whatever the number at the end was, remember the y-intercept is 0, comma that. So b is always the y value of the y-intercept. So this time they're giving us the opposite. They're giving us the y-intercept, and we have to find b. But we know that the y value, 1/2, that's going to be b. So we know b. We just got to figure out what m is. So I assume that the other piece of information they give us will tell us m. So first, so they're saying it's parallel to this line. But remember, parallel means same slope. So if we figure out what this guy's slope is, then the slope of the line we want is the exact same thing. So once I find this guy's slope, I'll be done, and I'll know, I already know the y-intercept, and then I'll know the slope. But just like in the previous problems, in order to find the slope, I'd better isolate y. So it's in that form mx plus b, y equals mx plus b. But I'm going to write 2x first and then the 4, because I want it to look more like mx plus b. And lastly, I'll divide by -3 every term. So y is by itself, it's -2 over -3, that's +2 over 3x. And then 4 over -3, that's -4/3. But I only did that to figure out the slope. Because remember, this is the equation of not the line I want, this is not the right line. But they said it's parallel to that line, so that means I want that slope. The line I want must have slope this, and then remember above we said the y-intercept was 1/2. Oops. But now that we know the slope and y-intercept, we're just ready to substitute those in, y equals mx plus b, and we'll be done. So m we just wrote was 2/3, x plus b is 1/2. There it is. Beautiful. Okay. Now the next problem, I think it's going to be sort of similar, except it's a little more difficult. The first piece of information perpendicular to this guy, I think that'll give us information about the slope. So remember that means the slope is reciprocal of the slope of this line that they gave us with opposite sign as well. So once I find the slope of the line they gave me, I better find its reciprocal and change its sign, and then I'll know the slope of the line I want. And I'll have to figure out what to do with this piece of information, because notice this is not the y-intercept. Because they're just saying containing this point. They're not saying this is the y-intercept. Not the y-intercept. So b is not -1. And definitely it's not -1 because the y-intercept is supposed to look like 0, comma something, but this is not a 0. They're not giving us the y-intercept, they're giving us a different point on the line, which will help us, but it won't give us the y-intercept outright. We'll have to do some work to find it. But first, let's do like we were mentioning. We're going to take the equation of the line they gave me and isolate y so I can find its slope, and then find the reciprocal of that and change the sign, and that'll give me the slope that I want for my particular line that I'm looking for. So 7y is -4x plus 1. If I divide both sides by 7, every single term, then I'll be left with y is -4/7 x plus 1/7. What really matters is this guy's slope is the coefficient of x, -4/7. But I want the reciprocal of that, which is, what's that guy upside down? 7/4, and opposite sign. So since that guy's slope was negative, I want positive. So that's the slope I want for my line. So for sure I know that I want y equals mx plus b, where slope m is 7/4. But b is something I don't know yet. That must be something I'll be able to find with that last piece of information. Let me bring this up a little higher. 7/4 x plus b. Alright, well I'm not really given b like we said. This is not b, because b is only the y value of a point if the x value is 0. But definitely the x value is not 0. So really I think I only have one choice. All I know is that this point is on the line. That means this x value and this y value should work when I substitute them in here. So I'm going to put an 8 there and a -1 there. And if I do that, then the only thing I won't know in this equation is b, and I should be able to find b. So replacing y with -1 and then x with 8, because those are the values from the point. And remember, when they say that this point is on the line, or this line contains this point, that really means, algebraically, if you substitute these values in, you should get a true statement. That's why I'm okay to substitute these values in. Alright, let's see if we can multiply these guys. It reduces though. 4 goes into 8 twice. So that number ends up being 7 times 2 is 14. And now I solve for b and I'll be all done. Because remember, all you need is m and b. And we already have m. Alright, finally, b is negative 15. Alright, that means I can take negative 15 and put it right here. Because that was the only thing I was missing. Y equals 7/4 x plus b. But b is negative 15. Whew, it's kind of difficult, huh? Alright. Good stuff. Let's try this next one. They're wanting us to find an equation, but they're not telling us anything about parallel lines or perpendicular lines, just different kinds of information. To say, write an equation of the line with slope. Alright. Well, first of all, they're just giving us the slope. So y equals mx plus b, I can replace m right away. Yeah, they're not saying it's parallel to the line with this slope. It's saying this is exactly the slope I want, so I should be able to replace it. And now, similar to the last one, this is a point, just some point on the graph, x, y. It's not the y-intercept, because again, the y-intercept would have x value 0. All I can really do is replace these x values and y values in here. I'm going to put a negative 4 where the y was, and a negative 10 where the x was. So negative 4 is going here, negative 10 is going for x. And I should be able to find out what b is once I substitute and solve for b. Okay, I can do a little reducing here. This 5 can go into the 10 twice. But be careful because there's still the negative there. So it's 2 times 2 with a negative, that's negative 4. Alright, now if I solve for b, I would add 4 to both sides. It looks like b is 0, huh? Okay. So the last step would be take the equation you kind of ended off with here when you didn't know b, and replace b with 0. Y equals, it was 2/5 x plus b, but now that I know b is 0, I can replace that and I'll be done. Anytime you have a plus 0 though, it's kind of silly. You might as well drop it. It's just y equals 2/5 x. Okay, good stuff. Let's try this next one. I imagine it's getting harder probably. That's kind of how they do these problems. They want us to write an equation of the line containing these 2 points, negative 2, negative 1, and negative 8, 8. So again, in order to find an equation, you need to use y equals mx plus b, and you need to find out what m is, and you need to find out what b is. So in the last example, we were able to find b later with using this point, but we had to find m first. So I think in this problem, we don't know m. We're going to have to go find it first. And of course, we have a formula for that. If you know two points on a line, like we saw a couple problems back, you're able to find the slope by using the slope formula. I'm going to label these points here as x1, y1, x2, y2. If I replace those values, y2 is 8, as I labeled it, y1 is negative 1, and from the formula there's a subtraction sign between those, and the denominator x2 is negative 8 because I labeled it that way, and x1 is negative 2. Now all I have to do is simplify and I'll have the slope. On the numerator, 8 minus negative 1, that's 9. And the denominator, negative 8 plus 2, because negative 8 minus negative 2, that's negative 6. And that reduces to negative 3/2. So there's the slope. Okay, at least I can do something with that. Y equals mx plus b, but now that I know the slope, I'm going to replace that for m. There we go. Okay, now your last step is to find b. Just like we saw in the previous example, if you know the slope, to find b, all you need is one other point. So really, I only needed the 2 points I was given to find the slope. At this point, though, I only need one of them. So I'm going to choose the first one, but if you use the second one, negative 8, 8, you're going to get the same answer as me either way. So I'm going to go ahead, yeah, substitute negative 2, negative 1 in here. So negative 2 for the x value, and then negative 1 for the y value. And this will allow me to find b, and then I'll be done. See, so to multiply 3 halves by 2, well, negative 3 halves by negative 2, I better put the 2 over 1. Across the diagonal, the 2's cancel, but it's a negative times a negative, so it becomes a positive 3 plus b. So to find b, the last step would be move the 3 over. And there, now we have it. b is negative 4. Aha! Alright, now I look back and see, where did I have y equals mx plus b with m filled in? There it was. And bring this guy down. Y equals negative 3 halves x plus b. But now that I know b is negative 4, I'm going to replace that. So it should be negative 3 halves x minus 4. That's the winner. Whew. Alright. This is tough. We're almost done though. Let's see. So notice there are no problems from section 8.1. Just because, remember section 8.1, it was us solving a system of equations by graphing the lines. And we even said when we were doing that section, you know what, this is not the best way to go, because what if you graph your line and it's a little skewed, it's not sloped as steep as it should be, or it's sloped too steep? Then the solution you think is the solution isn't actually going to be the right solution. It's all just because of human error, the way we graph it, and yeah, anyway, it's not going to work very well. So I'm just going to not even put that on the exam, section 8.1. It's just kind of a waste of time, and it's frustrating. If you get the wrong point, then you got to use this like a ruler to make sure your line's perfectly straight, and whatever. These methods are a lot better if you remember. Substitution, elimination, so much better. It's totally up to you. If you like one way better than the other, you can just use it every single time. Totally up to you. I kind of favor elimination, so I might do elimination, like for number 77 here. I already see the x's are aligned, the y's are aligned, the equal signs, the numbers, or the constants. You know, everything's perfectly aligned in order for elimination. So I'll probably do elimination, but if you're kind of in the boat where you like substitution better, notice x is really easy to solve for if you just move the 4y over. So it'd be pretty easy to substitute if you just isolate x like that and then substitute into the other one. But I think I'll stick with elimination for, But for the next problem, number 78, I think I'll be using substitution. Because you notice this guy, the second equation, it already has a variable by itself, so it's ready to be substituted. Since x is by itself, or x is equal to this thing, I can replace this x. Anyway, so that one I think is ready for substitution, but I think the first and the third I'm going to just do elimination. But don't worry, if you do substitution, you should get the same solutions. Alright, so I'm looking at, remember elimination, I look at the x's and the y's. I have to decide which one to eliminate. And the way to decide which one to eliminate is look at their coefficients and say, does x have smaller coefficients or does y have smaller coefficients? So the coefficients of x are 2 and 1 versus the coefficients of y are 3 and negative 4. So for sure the coefficients of x are smaller. I'm going to eliminate x. And you don't have to write this on your exam or anything. Just if it helps you later when you look back to know what you were doing, then yeah. So you look at the coefficients of x and you say, alright, what's the number that I can transform both those coefficients into by multiplying? I think it would be a 2, right? Because the top one, it's already a 2. The bottom one, if I multiply it by 2, it'll be a 2. But remember, they need to be opposite signs. So I'm not only going to multiply the bottom one by 2, I'm going to multiply by negative 2. So I'm going to keep the top one the same. I'm just going to rewrite that guy as is, because I didn't really need to do anything to it. But the bottom one, I've got to be careful when I distribute. Negative 2 times x, that's negative 2x. Negative 2 times negative 4, that's positive 8y. Negative 2 times positive 14 is negative 28. Okay, now if I add those together, the x's cancel. 3y plus 8y makes 11y. 6 and negative 28 is negative 22. And now I can solve for y fairly easily by dividing both sides by 11. That way y is equal to negative 2. But remember, in this section, your answers won't just be x equals or y equals. Your answer is going to be a point, something comma something. Because you're trying to figure out where these lines intersect. They gave you 2 lines and they're asking where they intersect. You better tell them the coordinates, you know, x and y. So we know the y value of the point, but we don't know the x value. This is where we're free to take this y value, -2, and substitute it into either of the first equation or the second equation. It doesn't really matter. I guess I'll take the first one. I don't care. The first one was 2x plus 3y is 6. Just going back to the very original guy. But I know now that y is -2, so I'm going to go ahead and replace that. And then I should be able to solve for x without too much trouble. Alright, if I simplify, 2x, that'd be -6 equals 6. If I start solving for x, I would add 6 to both sides. And 2x is 12. And the last step would be divide by 2. There we go. So I guess x must be 6. Alright, that means the solution is probably 6, -2. That's the point. Alright, then just to go over it, maybe we can check that answer, because it's probably been a while since we talked about checking that answer. In order to check what I think is the solution, I actually have to check it in both of those original equations. So the first one, 2x plus 3y equals 6. I'm going to replace the x and the y with those numbers that I think are the coordinates of the solution. And that better be a true statement. But not only that, just checking it in one of the equations isn't enough. You have to check it in both. Make sure they're both true. This is 12 minus 6. That's true. 6 equals 6. Okay, we're good there. But I still need to check it in the second equation. It was, in the original problem, x minus 4y equals 14. But I'm replacing the x and the y values with 6 and -2 respectively. Okay, so 6 is going for x, -2 is going for y. If this one's true, that means that this is the correct solution. 6, -2 times -4 is positive 8. And that's true, 6 plus 8 is 14. Okay, that means that the solution we got is the right one for sure. No question about it. I'd say on the exam, if you have time, I definitely do that. Because it's so frustrating if you know all the steps and you did everything right, you just made one little mistake like you missed a negative. This will check to make sure you don't do that. You wouldn't want to miss any points on a problem if you know you actually did it right. You just made a silly mistake. So number 78, we kind of talked about it's going to be easier to do substitution, I think, because it already has one variable isolated like that. If y was isolated, same thing. It doesn't matter who's isolated. So I'll do substitution. Alright. So that means I'm going to rewrite the first equation, the top one. 4y minus 7x equals 13. But where the x used to be, I'm going to replace it with this whole expression here. 2/7 y plus 1. So 2/7 y plus 1 is replacing that. Okay, and then all I really have left to do is solve for y, so I need to distribute the 7 in here. It's going to be a little tricky. I need to think of that 7 as over 1. Because that way, okay, here when I multiply 7 over 1 by 2 over 7, the 7's will cancel on the diagonal just to leave the 2 and the y. But then I'd still need to multiply the -7 by 1. -7 times 1 is -7. That's a little tricky. And now there are like terms here. 4y minus 2y is 2y. Now if I want to isolate y, I'm going to move the 7 over first. So that way 2y is equal to 20. And then lastly, I'm going to divide by 2. And that'll leave me with the y value of the solution, but not the x value. I'll have to find that soon. Okay, so our solution is going to be something comma 10, because that's the y value we found. So to find the x value, I think we mentioned this before, but the good thing about substitution is, once you find one of the values, x or y, it's definitely the easiest to substitute it back into whichever equation had a variable by itself. So this guy right here, x equals 2/7 y plus 1. I know it doesn't look easier, but it is easier. X equals 2/7 y plus 1. Yeah, if I put y equals 10 right here, notice it's easier because y is already by itself. I mean, sorry, x is already by itself, so x will be easy to find. So 2/7 y plus 1, but y is a 10. So I'll put a 10 there. I have to put it over 1 in order to multiply it by 2/7. And then nothing reduces, so I just have no choice but to multiply across. 2 times 10 is 20. 7 times 1 is 7. And now in order to combine these terms, 20 over 7 and 1, I better put the 1 over 1 and find a common denominator. Of course, between 7 and 1, the common denominator is 7. So I'll multiply the second fraction by 7 over 7. That'll make it 20 over 7 plus 7 over 7. If I add their numerators, that's just 27 over 7. And that does not reduce, unfortunately, because that's our terrible x value. 27 over 7, come on. And like I said before, I think when I get a solution with a fraction, if you want to check your answer, you might just do it all over again. If you get the same answer, then you did it right. Because, man, checking a fraction answer is not fun. Okay, let's try this last one here, and then I think we got a good feel for it. So I wanted to make sure we go over one that has decimals and or fractions, because that way, just to remind you, you don't have to put up with that. This is going to be really hard to solve using either method if I leave the decimals and the fractions there. But remember, for decimals, we have a trick. If you want to get rid of decimals, you can multiply by 10 or 100 or 1,000. I only need to multiply this one by 10 because each of these numbers only has one digit beyond the decimal. Maybe I'll think about what to do with the second one soon, but not yet. So what would that guy become if I distribute the 10 onto all three terms? 10 times 0.2 is 2. That would become 2x. 10 times 0.3y would be 3y. And then 10 times 1.7 is 17. That's so much better. I'd much rather deal with that than 0.2x, blah, 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 blah. And then for the second equation, you have a bunch of fractions. I'm going to multiply by the least common denominator to try to knock out all those fractions. So I see my denominators are 7, 5, and 35. The LCD is going to be 35. So see what happens. That times this fraction, that times that fraction, and then times the last one. Okay, maybe I'll be careful. If you can see how it reduces right now, that's good, and you can kind of skip ahead. But just in case there's someone out there that just wants to be really careful and doesn't want to skip steps, that's good. So first I'm doing 35 times 1/7 x. I'm just going to write that and then see how that reduces later. And then 35 times 1/5 y. I'm going to write that out and see how that reduces later. And then lastly, 35 times 29/35. So each of those 35s, I'm going to have to put them over 1 to see what reduces there. So the first one, 7 can go into 35 to leave 5. That means this whole term will just become 5x. And then for the second one, 5 can go into 35 7 times. Oh wait, I should have put a y, huh? Hello. That's a y, hello. Anyway, 5 goes into 35 7 times, so this term becomes 7y. Again, a y because there was a y to begin with. I don't know why. What made me change it. On the right side, the 35s cancel on the diagonal just to leave the 29. So I think this system of equations is a lot better. I had this top one, 2x plus 3y equals 17. That came from the decimal equation, and then the green one, 5x plus 7y equals 29. That came from the fraction equation. So now I'm kind of starting from scratch. Now I'm kind of solving this using elimination. If I want to use elimination, I'm going to think, all right, which of these variables, x or y, has smaller coefficients? Well, x seems to have smaller coefficients. 5 and 2 are smaller than 7 and 3. So I think I'll eliminate x. Although it doesn't matter, you should get the same solution either way. Okay. So I look at their coefficients now, 5 and 2. What's the smallest number I can think of that I can transform 5 and 2 into? I think 10, right? That's like their least common multiple, kind of. So I want them both to become a 10. That means the top one needs a 2 to be multiplied. That would make him a 10. The bottom one needs a 5, because 5 times 2 is 10. But one of them needs to be negative. It doesn't matter which one. Yeah, if you did negative 2 on the top and 5 on the bottom, it doesn't matter at all, really. So, okay, I think that'll do it. Let me distribute the 2 in the top one. 2 times 5x makes 10x, which is better because that's what I was trying to do. 2 times 7y makes 14y. 2 times 29 makes 58. Alright, and the bottom equation, I'm multiplying everybody by negative 5. Negative 5 times 2x is negative 10x. Negative 5 times 3y is negative 15y. Negative 5 times 17 is negative 85? Yeah, 85. There we go. Alright, now we're able to add these together, and the x is cancelled, because 10x and negative 10x makes 0. 14y and negative 15y is negative 1y, or negative y. 58 minus 85 is negative 22. Negative 22? No, what the heck? 27. Hello. Hello, there we go. But negative y equals negative 27. That means I need to get rid of that negative. So you can multiply both sides by negative 1 or divide. That negative over the negative will make a positive 27. Holy shamoles. Alright. I don't know why. It seems like we always end up finding y first and then x, huh? That doesn't always happen. I'm not sure why that just seems to be the case here. Sorry. But there's the y value. Now we need to find the x value. So I look back at all the equations we had, and I can substitute y equals 27 into any of them. Which one looks the nicest? I feel like this one looks pretty good here, huh? It's kind of got smaller numbers. I'm going to go grab that one. Although it doesn't matter, you can substitute y equals 27 into any equation that has an x and a y, and you should find the same exact value. Just at this point, when you're scanning through them, just trying to find the easiest one with the smallest numbers, that's all. Alright, but we think y is 27. Okay. Now we can find x. Okay, be careful here. So it's 2x plus, see, 27 times 3 is 81. Equals 17. Now I have to solve for x. I'm almost done. This is where it's easy to make a mistake because you're like, oh, I'm home free. So you're kind of like not using as much brain power as you should because you feel like, I don't know, you're almost done or something. And 17 minus 81 is negative 64, I believe. Now the last thing to do is get rid of that 2. I'll divide both sides by 2, and now we'll finally have x. It's negative 32. Whew. So what's our solution? Negative 32 is the x value. What was the y value? 27? Yeah. There it is. Beautiful. And that one, even though those numbers are big, I mean, I think it's okay to check those, but I think you don't have to check them in the originals if you don't want. If you want, you can check them in the kind of nice transformed versions we had, where is it? And it was kind of scribbled. Here, these guys. If you check it in there, that should be fine. Whew, alright, that was fun. We're almost done. Last couple problems here, you guys. Man, if you got this far, you are really a go-getter. You should be proud of yourself. Alright, so section 8.3, if you remember, this is the word problems for systems of equations. So we're having to set up our own system of equations. So you can imagine we'll be being asked for two things. Something that we'll call x and something that we'll call y, or whatever variable you like the best. And then we'll set up a system of two equations and then solve it like we did in the previous couple problems. So okay, what does number 80 say? I'm just going to read through it to make sure it makes sense. A hockey team receives 2 points for a win and 1 point for a tie. The Wildcats once won a championship with 60 points. Okay, so I'm thinking 60 points is made up of however many wins and however many ties, so it's kind of like mixed up between them. They won 9 more games than they tied. How many wins and how many toes? Oh my gosh, autocorrect. How many ties did the Wild? Oh my gosh, oh, that's funny. Ties, okay. That's the clue right there. I'm going to call, and it's up to you if you want to use X and Y, or I guess this one is kind of clear, W for wins. I'll say W is the number of wins. And then T is the number of ties. Whatever they're asking for, that's what you want your variables to be. Number of toes. What the heck? Oh, geez. Oh, okay. So let's see. We know that they received 2 points for a win and 1 point for a tie. And they made a total of 60 points. Okay, so brainstorming, this is an optional step, but if this kind of helps, it's good. 60 points is the total, so it's how many points from their wins, which we actually don't know. That's not W, because W is the number of wins, the number of times they won, not the number of points they got from those wins. Because remember, you get to double. It's two points for every win, plus the points from their ties. So, well, they've made W, that's the number of wins, and they get 2 points for every win. So if they won a certain number of times, you just multiply that by 2, and that's how many points they got. Plus, how many points did they get for each tie? Well, they had T number of ties. They get 1 point for each, so that'd be times 1. That's how many total points they made. And if you want, you can drop that 1. It's kind of not really there for any reason. Just kind of there to help me remember where it came from and how to set it up. There's one equation. What else did they give us? The second sentence, or third sentence will probably give it to us. They won 9 more games than they tied. Okay, they won, which is W, 9 more. That means you're adding 9 to something. Games than they tied. Well, how many games did they tie? We called that T. So I think so. The number of wins is 9 more than the number of ties, I guess. That's a way to rephrase it to make it easier. Number of wins is 9 more than the number of ties. All right, there's our 2 equations. I think since the second one, I'm thinking now, how do I solve this system? Since the second equation has one variable already by itself, I'm going to use substitution. That's usually how I decide which one to use. If one of the equations already has a variable by itself, I'll use substitution. If not, I'll just use elimination. Okay, W is equal to T plus 9. I should be able to replace this W with that. So I'm going to rewrite the top equation, but W missing. 2 times W plus T is 60. And W, we know from the second equation, is T plus 9. Alright, if I solve this, I should know T. And once I know T, I can find W. If I distribute the 2, I'm left with 2T plus 18, because 2 times 9, plus the T that was outside the parentheses, equals 60. There are a couple like terms. 2T and T make 3T, plus the 18 is 60. Let me isolate T by subtracting 18 first. That way 3T's by itself, it's equal to 42. Yeah, okay, and then last step would be divide both sides by 3. Alright, 3 can go into 42, let's see. 14 times. Alright, so they must have tied 14 games. Because that's the beauty of calling it T instead of like X or Y. Because if right now I found Y, for example, I'd forget what Y was. Is that the number of wins or the number of ties? That's why it's kind of nice to have T and W or something that actually represents what you're talking about. And then above, what did we say? The number of wins was 9 more than the number of ties, right? I think that was the equation we had above. But now that I know T is 14, I can find W. 14 plus 9 is 23. Wins. Alright, there we go. And since this is a word problem, this is one where it would prompt you to say, and make sure you write your answer in the form of a complete sentence or something. So I'd say something like the Wildcats had 14 ties and 23 wins. Something to that effect. Whew, alright. Oh, shoot, sorry. Okay, last one. So let's see, soybean meal is 16% protein and cornmeal is 9% protein. How many pounds of each should be mixed to get 350-pound mixture that is 12% protein? Alright, first things first, this is one of those mixture problems, which is tricky. And I think the way we covered them, I said I like to draw a picture of 2 things actually being mixed together. Somehow that makes it easier. But first I'm going to see, what are they asking for? How many pounds of each? Okay. I'm going to call those the variable. Something's equal to the number of pounds of, let's see, the first thing they mentioned was soybean meal, whatever the heck that is. And the second thing they mentioned, I want the number of pounds of cornmeal. Okay, I know what that is. Alright, you can call those X and Y or something, but I might call them S for soybean and C for corn. Something like that. But you can call them, yeah, X and Y if you want. Doesn't matter. Okay. So I'm going to draw pictures here. I'm going to say this is like a vat of soybean meal, whatever. Sure. Meal. And we got S pounds of that. However many pounds that is. We're going to take that and combine it with some number of pounds of cornmeal. Called it C. And we're going to end up with a mixture that has how many pounds? 350 pounds. Alright, then I'm going to label their percentages so I remember. The soybean meal, what did they say he had? 16% protein. The cornmeal had 9% protein. And we want the mixture to have 12% protein. Alright, well, one equation right away is I can get from the number of pounds. Because you're taking S pounds of the soybean meal, you're adding C pounds of the cornmeal, and you're ending up with 350 pounds of the mixture. So that first equation is pretty simple right away. Oops, you know what, I realized I shouldn't have written it in red because that makes it seem like you're using the percentages. I'm sorry. You're not using the percentages, you're only using the number of pounds of each thing. S pounds, C pounds, and 350 pounds. So S plus C is 350. So that equation kind of represents how many pounds of each that you're combining. The second equation, though, will have to do with the percentages. And I guess it'll involve how much protein is in each. Alright, well, how much protein is in the first one? Well, if you have S pounds of it, and 16% of those pounds are protein, and it's 16% of S. And how do you find 16% of something? It's 0.16, the decimal form of that, times S, the number of pounds. And then similarly for the second guy, if you have C pounds of cornmeal, and 9% of that cornmeal is protein, that means the decimal form of that guy, 0.09, times the number of pounds. That's how much protein will be in that one. Now remember, to take a percent and make it a decimal, you move the decimal point where it is to the left twice. So this guy twice. And then on the right side, same kind of thing. I have 350 pounds. 12% of that mixture is protein. If I want to know how much protein there is, it's 12% of that amount, 350. Whew. Okay, let's see. Let me multiply that out. I can't really do much with 0.16S or 0.09C, but 0.12 times 350 is 42. That's kind of a nice number. So I'm going to get rid of that. Just use this guy. So I have this system of this equation, C plus S, or S plus C equals 350, and 0.16S plus 0.09C is 42. I don't really want to deal with decimals, though, so I think I'm going to multiply this by... I'm actually going to have to multiply it by not only 10, but 100, because 10 would only move those decimals to the right once, which would make this guy a 0.9, but I'd rather move it twice to make it a whole number 9. Okay, what will that become? 100 times 0.16 will move its decimal twice to the right, just make it a whole number 16. Same thing with this guy, it'll make this a 9C. The only bad part is 100 times 42 is 4,200, or 4,200. Kind of a big number, but not, I think it's worth the sacrifice. And then the other equation we haven't touched yet because it's really nice is C plus S, or S plus C is 350. There we go, so that's a good looking system of equations. And to me, I think since the S's are aligned, the C's are aligned, the equal signs are aligned, the constants, I'm just going to use elimination. So, okay, which guy, S or C, has smaller coefficients? C's coefficients are slightly smaller because there's, 9 is smaller than 16. So I think I'm going to eliminate C. Although you eliminate S, that's fine. That means if I want to eliminate C, though, I need their coefficients to be the same number, but opposite signs. Since the top's coefficient is 9, I can easily make the bottom's coefficient another 9 by multiplying it by 9. But to make them opposite signs, I better multiply it by -9, not just 9. I think that'll do it. I'm going to copy the top equation down because I didn't need to do anything to it. 16S plus 9C is 4,200. The bottom equation, if I multiply everybody by -9, it'll become -9S minus 9C equals, it'll be negative 3,150. All right, now we're ready to add these guys, and we'll eliminate C, and we'll be left with S. All right, C's are gone. 16S minus 9S is 7S. That's equal to, let me see if I subtract these guys, 1,050. Okay. And then let's see if, hopefully 7 goes into that number evenly, huh? So I have to divide by 7 to isolate S. Let's see, I'm going to try that. 7 into 1,050. Well, 7 goes into 10 once. Goes into 35 5 times. Okay, this is looking good. It goes into 0 0 times. Okay. So 150, there we go. And S stood for soybean meal. So you need that many pounds of soybean meal. But I think they want to know how many pounds of both, so I better find C also. And I can look back and see which is the nicest equation that I can plug that into to find the other guy, but clearly I think this is the nicest equation. Come on. Can't get better than that. So S plus C is 350, and that'll allow me to find the other value, C. You might even be able to guess the answer looking at this guy. So if S is 150, I should be able to put that here. S plus C is 350, and I can isolate C by subtracting that 150 to the right side. Okay, there's C. C must be 200. So 200 pounds of, remember C stood for cornmeal. Alright, so we can say something like in a sentence, what did we say, 150 pounds of soybean meal should be mixed with 200 pounds of cornmeal. That's good. Alright. Alright, you made it, you guys. Hopefully that helps a lot. If not, please let me know if you have any questions or concerns, or you want to know why something's wrong that you did, or you're questioning something. Just let me know, no problem. Alright, sorry that took so long.